So basically, we're going to talk about empowering maintenance. And really, maintenance is one of the toughest jobs in any plant, and that's really to keep the company in business. When you stop and think about it, basically, you've got maintenance people who have to be the jack of all trades. They're dealing with lots and lots of different technologies, larger and larger facilities, and basically, they're trying to keep everything going with very little technology and very little equipment available to them. So consequently, what's happening is they're being trained on certain items and technologies, and then necessarily not being able to apply that knowledge until something breaks down, until they have to deal with the situation, which could be years later. And this creates all sorts of problems. So when you talk about being a jack of all trades, it's impossible to be an expert in all of them. So you might have some versatility, but you're certainly not an expert. So consequently, when you're looking at maintenance and you're looking at processes and revenue, you can really come down to the equation that no production means no revenue. If your processes aren't working, you're out of business. It's as simple as that. You have nothing to sell. Have nothing to sell, there's no revenue. So what are some of the issues affecting maintenance? Well, you're dealing with larger, more complex process systems. Basically, they're spread out over larger areas, maybe even multiple cities, towns, sites, whatever. And you're dealing with many, many technologies. You know, hydraulics, mechanical, electrical, pneumatic, software, all of these things that you have to be an expert on. And consequently, that makes it very difficult. And although you train maintenance on all of these different things, you might send them for 2, 3, 4 weeks of training. As I said before, they don't use it all the time. So by the time you get around to actually needing to use it, you've forgotten what you've learned. And then what typically happens, the guy's stumbling around saying, where's that computer with the software on it? What's the latest drawings? Where's the manual? How do I tie to this thing? How do I interface to it? I don't remember. So he's basically spending a lot of time trying to remember what he learned, and consequently can get himself into deeper and deeper problems. So then you get more reliant on third-party organizations to do that kind of training and that kind of support for you. So basically, you're now calling another company that says, hey, you know what, I need you to come in and take a look at my drive, or I need you to come in and take a look at my SCADA package, because I don't have that expertise on site. And now I'm at their mercy. I'm at their mercy from cost. I'm at their mercy from availabilities. And then, of course, you're dealing with greater competition, which means now companies are running with basically their processes running in excess of 95% uptime. So consequently, that means I have less finished goods inventories, which means I'm relying on my process to basically generate the product I need, ship it out the door virtually in a single line assembly type arrangement, and having very little backup supplies or very little inventory available to ship, which means that if I can't ship my product, my customer has to go elsewhere. So basically, you see plants running very lean when it comes to maintenance. You're getting basically multiple shifts, 7 days a week, where people are basically working, you know, excessive amounts of overtime to try to keep things going and to meet the needs. As I indicated before, when you're dealing with larger and larger facilities, you're increasing the amount of time to get to the problem and resolve the problem. And then, of course, you're dealing with processes like water, wastewater, power generation, et cetera, which run continuously. There really isn't any ability to shut it down, because you shut it down, you have customers that are no longer getting what they need, and consequently, it creates major, major problems for not only your revenue stream, but for those customers. And as I indicated before, third parties are becoming more common, particularly when you're dealing with remote locations or products that you don't have expertise on board with. So all of these things become more and more pronounced as you go. And then the other big cost issue is cost itself. You're trying to reduce those costs, which means I have less maintenance people, less money for diagnostic equipment, less money for spares. All of these things impact on how maintenance has to do to keep the processes running. So what is a motor control center, basically? Well, a motor control center really is a way to distribute power to the various loads and devices that I have through means of really a common bus and a power stab assembly. So a way to basically move that power to different devices easily. And then I need to provide some way to control those devices. And that's done typically through contactors, breakers, soft starters, and drives, VFDs, or variable frequency drives. It provides a safe and easy method to install, remove, and reconfigure modules to meet process changes. So if I need to basically go from a 5 horsepower to a 10 horsepower, or from a standard drive to basically a VFD, it gives me that flexibility. And it also allows me to speed up maintenance by allowing for easy replacement of defective assemblies with new ones. Because really, you don't want to get to the point where you're repairing assemblies out in the field or at the site. Not only does it take longer, but it also creates a lot of interesting situations, some of which are related to safety, because now that I'm working on something out there, I have the tendency maybe not to work in the most safe practices available, or I might be working on something and accidentally damaging something else in the process. So all of these things work against you. So you want to substitute and change something out very quickly. Motor control centers come in two basic flavors: communicating and non-communicating. So communicating is typically networked, and it always relies on an upstream master or SCADA system or DCS system that typically use a wide range of communications, whether it's Ethernet, Profibus, DeviceNet, et cetera. It doesn't really make a difference. And these are other areas that your maintenance guy has to be an expert on. And then you're dealing with non-communicating or hardwired MCCs, which are typically wired back either directly to a panel somewhere on the plant floor, which has a PLC in it, and that in turn takes those signals, digitizes them, and sends them up to the SCADA system. Or they may be hardwired back to a control room somewhere, or even hardwired back to actually controls on the MCC bucket itself. All of those are very, very common. So some thoughts. What if your process can tell you when you have a problem developing and before you experience unscheduled downtime? What if your process can alert you to potential problems and provide maintenance personnel with the needed support to correct the problem with little or no process interruption? And what if your system can provide enhanced maintenance tools and personal safety that can be installed on old and new motor control centers? Well, that's where you get to the next generation, which is called smartMCCs or intelligent MCCs. And they provide basically the characteristics of a networked MCC on steroids, which is pretty much what you consider a networked MCC with enhanced maintenance functions that increase process reliability and minimize downtime. And the way they do that is by basically pushing information directly to the maintenance people by way of typically an HMI or a GUI interface. And you'll see typical things like the information and types of screens that you might find there. And that information is typically updated on the various loads and provides basically a single point of access to that information from the maintenance standpoint. That has nothing to do with the SCADA, nothing to do with the process side. Typically, smart MCCs have what I call a default or a summary page, which will always show you. And that summary page will always give you information at a glance to show you what the status is. It's a graphical representation, typically, of the motor control center itself, showing where each bucket or wrapper is located and the orientation of those wrappers and the state that it's in. And you're going to find typical information there that's alarms, alerts, load status, and general operating data. You're also going to find that motor control centers or smart centers are typically password protected, which means there's different levels of password to get you to different features. So some of those features might include things like actual values, parameters, analysis information, trending information, event history. What passwords allow you to do is not only lock out people from getting to information, but it also allows you to train on what they have access to, which means that if your operator only needs to know the first page of there, the summary information, then you only need to train them on understanding what that means and how to read that. The next level in might be something that your maintenance people need to know. Third level in might be something for maintenance supervisors, fourth level engineers, et cetera. So again, by doing that, you control the amount and consequently the learning curve. So what makes MCC smart? Well, MCCs provide a single point of connection to the upstream system or the SCADA system. And what that does is basically allows you to have predefined mapping tables, which means that when you get a smart MCC or an intelligent MCC, you're already getting a mapping table that says how to communicate with this, and that mapping table is usually standard. So regardless of the motor control center that you're getting, how large it is, what's inside each cell, the mapping table usually stays the same, which means that when the MCC arrives on site, the information is available at time of order, so the programmer who's doing the SCADA system can actually interface to it and even test it at the factory without ever waiting for it to arrive in the field. So consequently, that minimizes a lot of problems that you would have. It also allows you to have the ability to have an MCC that is completely protocol neutral, which means no matter what it's going to talk to in the upstream communication to the SCADA, whether it's Profibus, Ethernet, IP, Modbus, irrelevant, the internal mapping table stays the same. All it is the protocol that you're accessing that information with that's going to change. So consequently, it means that from an OEM or from a customer standpoint, you eliminate a lot of variations in the motor control center itself. It also provides high-end functions like web server, FTP servers, OPC servers, which basically allow you easy ways to access the information. So it's when we were looking at the screens there and you wanted to basically see what was going on, well, they're inherently web-enabled, which means that you can dial in from any web access point and see exactly what is going on the screen itself. Consequently, if you want to get information, let's say of what the logging information is, you can download that through the FTP server. And if you want to tie it directly to a SCADA package without using a standard field bus, you have the ability to do that through the OPC server. So typically you have the ability to access information basically on an on-demand basis, which is things like reading files, to actually getting control information, which is over the real-time system, typically the OPC or the field bus. So again, your control commands, stop, start, speed references are deemed real-time. Things like, well, what's the alarm history? You know, tell me basically what the current was doing, you know, in the last 24 hours. Those are all on demand. You ask a question, the system sends you the information. Everything else is sent automatically without you interacting. So MCCs provide, or smart MCCs provide a lot of maintenance tools. And those maintenance tools look like things like bills of materials, which you can see sort of graphically here, wiring diagrams, performance data, alarm limits and alerts, and logging and trending information. All of this information is very key in knowing the performance and how to solve and deal with problems that may develop. So what you typically want to do is have the information which is always available to you. One of the typical problems that happens in maintenance now, and one of the issues that always addresses, is what do I do when I have a problem? The operator calls me and says, you know what, something's wrong with my process, it's not working right. All right, I have to typically go to wherever that location is, go to that MCC or that motor control center, go to that cell, open it up, take some readings, try to figure out what's going on. Well, that all takes time. And then when I have an idea of what's going on, then I might need to say, well, I got to go get back and get some drawings, I got to go back and get some parts, I got to go back and get all this other stuff before I can even do anything about it. Meanwhile, you might be down, and that's downtime that is costing you money. So you want to shorten that period of time considerably to virtually zero if you can, by making sure that he has all the information he needs before he even goes to site. He knows what cell he's talking about, he knows what the wiring diagram is that's available to him, he's not stumbling around trying to find it. He knows what the actual bill of material looks like, he knows the part numbers, he can call stores, he can call the distributor, he can find out if it's available, have it there on site when he arrives, pick it up on his way to the site, whatever. But when he gets there, he has everything he needs to solve the problem. That's key. We want to reduce the amount of downtime. So some other ways of doing that is what's called load profiling. Smart MCCs or intelligent MCCs are labeled that for a reason. They're intelligent, they're smart, they understand what the load is, they learn, and that's key. So they're going to go out there when you start them up, when you commission the load, whether the load is a brand new installation or an installation that's many, many years old, it's going to go out there and learn what is normal. And it's going to develop a pattern and lock it into its memory. And then what it's going to do with user-definable limits and parameters, it's going to look for trends, changes to that profile, things that no longer fit. So for instance, if a motor runs at a certain current level all the time, and for some reason it's running outside of that limit all the time now, something has changed. And instead of the operator waiting for that to cause an outage to maybe shut down the system, to shut down the process, the system is going to push it out and say, there's something wrong here. It's no longer doing what it should do. Therefore, you should take a look at it and determine what the next appropriate action is. And it's doing this in real time. So it's constantly monitoring, looking for changes in the profile, changes in the pattern. And consequently, once it sees a change, it's going to push that information out to you, whether it's over a LAN connection, a cellular modem to a pager, or it's going to push it out over a hardwire connection to a contact that signals a light, sounds a horn, whatever. It's going to make sure that you know about it before it shuts you down, and that's key here. The system has to basically be proactive. It's got to let you know there's a problem before that problem causes you grief. And the other thing it needs to be able to do is provide you remote access to the system. Because a lot of cases, as we said before at the very beginning, the maintenance guy is not there. He has to travel to that site. The site might be a remote pumping station somewhere. That may take you a day to get to it. Well, I want to be able to know. The system needs to tell me that I have a potential problem forming, and it's going to tell me this is the problem I detect, and now you're going to make a determination what needs to be done. Maybe it did trip. Maybe it went off on a thermal trip. Well, instead of me racing up there a day to go press a button to reset it so the process can run again, I should be able to go online and say reset. I should go online and say change the value from 10 amps to 15 amps. So I have that ability through password protection to actually change what needs to be there so my process can continue to run. Now, grant you, there are limitations and things that you need to be aware of. For instance, you might say, you know what, I know that this is not a safe value to put it to, but the process needs to run. So I'm going to sacrifice a motor in basically the betterment of my process to keep my process going, and that's fine. That may be an acceptable thing. It's a 5 horsepower motor. I can have one in the truck. I can drive it out there. But at least in the meantime, the process is running until I get out to the site. All of those things are at your discretion. Maintenance needs to make that decision, not the process making the decision when it's going to go down. Other thing you're going to have is a single point of access. Basically, you want one point to communicate with your system for control, monitoring, diagnostics, troubleshooting, changing layout or parameters as we just talked about, or even looking at the event log. What happened? When did it happen? When did somebody acknowledge that event? And when did the event get rectified or corrected? I want to know that because to know the order of when things happened is very important for troubleshooting. It's also very important to know how long something's been off. Maybe this happened to be a critical sterilizing process, and I need to know from some government regulation how long I wasn't doing this process, so I know how much a product is affected. I need to know that. So this is all important to understand my process and understand weak points. But it's also important for maintenance, because maintenance doesn't want to have to use multiple tools to get his information. He wants to use one tool connecting to one location to get everything I need to know about everything in that device. I don't have time to search around for multiple programming cables or multiple software packages or remember multiple training courses. I don't have that time. I want to have one thing that I need to do that gives me all that information. And the other key thing that comes about is enhanced safety. Okay? You don't want to ever have your maintenance guy going into that live load module for no reason. And to do that, you want to basically make all that information available to him from the screen from a safe distance, which means all that data is available without putting on all of this protective equipment. I want to be able to do whatever I need to do, maintenance mode, maybe jog the motor, maybe be able to check for a sound in the bearing, put a new drive belt on, without ever going in, without being relied on the SCADA package. The SCADA package might be down for service when your plant is down. And my maintenance guy is not going to stand around waiting on the SCADA guy. He needs to have a way to do things manually through the operator interface without actually pushing the contactor in with a screwdriver. He needs to be able to do that safely. So consequently, if you look at our little maintenance man here in his protective garb, you see some of the issues that he's dealing with. Well, he can't see very clearly through his mask. He certainly can't use his tools very easily because he's wearing very heavy gloves, which makes it very cumbersome for him to take readings or make adjustments. It's very hard for him to move around. He's wearing all this bulky stuff. He's actually causing more of a problem. He's trying to work in a small confined space. He's banging into things. He may cause a bigger issue. He may break other pieces. And of course, you have an issue. Some of these plants get very hot in the summer. He's wearing all this additional heat-generating garments that is going to make him very uncomfortable. And of course, he's going to have to take his coffee break or go to the washroom or have lunch, which means all that stuff has to go off to go do what it is, to come back, and that just adds more and more time to maintenance. So one of the questions that always comes up is, all right, I have a SCADA system. Why can't it do that? Well, SCADA systems are designed for the process. Their job is to deal with the whole process, not the individual element. Where you might be talking about one motor when we're talking about a smart or 100 motors in an MCC, he's talking thousands of motors, thousands of sensors, thousands of heaters, thousands of pressure transducers, whatever. That's what the SCADA system is designed to do. The process, deal with the tension loops, deal with all the recipes for that. It has no time to deal with the maintenance issues. So consequently, nor are they ever designed as a maintenance tool, nor do they have the bandwidth to be a maintenance tool. If it was going to do profiling and diagnostics of a load, it would have no bandwidth left to do anything else, because it would be sampling that every second, every half a second, and trying to figure out patterns. It just can't do it. And it's not designed to deal with predictive analysis. So basically, it can't do that without jeopardizing its key function. When you think about a process plant or a large process, it's really a pyramid type operation. You have your SCADA package and you're going all the way down. And way down here is you're dealing with all your sensors, your motors, your valves. That's down at this level. He hasn't got time to worry about this level. He's dealing with the whole thing. So what's next when you talk about smart technologies? Well, you want to have field installable kits. Virtually, I'd like to be able to get a kit that I can install myself wherever I want to, on any product I want to. I don't necessarily want to buy it out of the factory as a new MCC. I want to be able to retrofit whatever I want, when I want, pick and choose. Which means I need a kit that requires no special knowledge to put it together or install it, that will support any combination of smart or not smart cells. So I want to be able to pick and choose. This cell is important to be smart, but you know, if this one's running a bathroom fan, I really don't care if he's on the process or not. He just happens to be in the same motor control center. But he's not critical to my process. So I want to pick and choose. I want to be able to have plug-and-play designs that snap together. Why? Because I don't have time to maintain it. The system has to be simple and easy to use. If there's somebody who has a problem with it, I want to be able to replace a cable, expand the system, change the system very easily. It's got to be a standard product, not a piece of customized automation, which means it's got to come with a complete document package. It's got to come with user manuals, installation guides, troubleshooting guides. It is a product, not something that you wrote for one application for one customer. It's the same thing no matter who it is, where it is. So it has a history. It's got basically support for that product regardless of where you're going or who you're dealing with. And it's got to be self-monitoring and fail-safe. It's got to take care of itself too. I don't have time to worry about it. I already have a problem dealing with everything else. It's got to tell me when it has a problem, when it needs me to deal with it. It's got to be self-configuring, which means the screens and the algorithms need to change based on the load types or the application I'm using it on. It needs to be able to be smart enough to tell me what the default values should be. Because I don't know. First off, I've never had the system. I don't really know what I want it to do. So until I basically turn it on, it's going to have to give me some valid information with the least amount of interaction. And it's going to be a plant-wide design, which means it's going to cover all my loads, all my voltages, all my currents, whether it's MCCs, switchboard, or switchgear. It's got to be the same product. I don't want a different product for every piece of equipment I have because that increases my learning. That increases the complexity of my system, and I'm trying to simplify it. So I'm going backwards if I go that route. So it has to simplify it. Regardless of the device it's on, manufacturer, whatever, it's got to be completely independent or neutral. Why would you go smart? Well, the major reason is reduce or eliminate downtime. That's really the whole reason here. This is why we're having the conversation. How do I turn unscheduled downtime into scheduled, controlled downtime? Well, using technology like smart or intelligent MCCs is the way to do that, because it allows you now to schedule your downtime and decide when that downtime is required. And it does that by allowing me to know what my process is doing and how it's performing, so I can decide when and if it needs to shut down, and when it does shut down, what exactly is going to be done. So I want to basically maintain the equipment when it needs to be shut down and maintained, and not because of run hours. I want to maintain my equipment, and I want to know what pieces of equipment need to be dealt with so I can have all the parts and resources available at that time so I can service it in the most efficient manner. And I want to have all the correct information where I need it to be. I don't want to be hunting around at the last minute and say, oh, geez, you know, I got into this project and I don't have the right drawings. I don't have the right software. I don't have what I need. So now I'm in scramble mode trying to find it. I don't want to be there. I want to have sure everything is there waiting for me when I start the project, so that I can effectively deal with it quickly and easily. I want to be able to benchmark my system performance, because every system has a weak point. Well, I want my system to run more and more. I'm expecting it to give me more and more productivity, more and more process, maybe a higher throughput. Well, I need to understand where the weak points are so I can address them and make them stronger. And in order to do that, I need to look at historical data. I need to see where my limits are, because there's always limitations. If I fix this, I can increase my speed 5%, or I can do a new product. I can run longer because I know what my system is doing. Consequently, knowledge is king. I want to enhance safety for my maintenance people. I want to reduce workplace hazards, and I want to keep people out of harm's way. Everyone hears the expression arc flash. Well, that's one of major. But how many people have opened up a cell in even maybe your house and playing with something and you get a shock? Well, imagine when you're talking about a shock and dealing with 38 kV. It's not a shock anymore, it's death. But that's what you want to do. You want to avoid that. You want to keep your people from getting in harm's way where they don't need to. Even protective equipment isn't going to give you infinite protection. The only way to get infinite protection is take yourself out of that harm's way and get the information you need and the availability to that information from some remote, safe location. Hence the screen, hence the remote web server, whatever. Really, there should be no reason to ever go in a live cell. And you want to basically reduce commissioning times, particularly for new projects. Because if I can have my motor control center or my switchgear arrive fully configured, ready to go, that I drop it in place, hook up the communication, hook up the power, hook up the load wires, I'm done, that saves me a lot of time. All projects basically have time frames. And a lot of projects have penalty clauses if you miss those. So you want to have everything that's done outside at the factory done first, so when it gets to site, all I have is the minimal amount of work to do. All the addressing, all the commissioning, all the software debugging is already done. You want to basically get a way to have something that produces higher value with a lower installed cost. So virtually, if you can sort of look at the graph here, you see how actually your cost comes back in line. And basically, you get premium features for virtually the same cost as a networked MCC. Smart or intelligent MCCs are going to give you that advantage because you're already paying for the internal network at any rate. Why not get a little bit more value for the money you're going to spend? So the question comes down to, what is the true cost of downtime? Lost revenue? Yes. Lost wages? You have all these people who are supporting your process standing around twiddling their thumbs. You're paying them. That's money going out the door. You're not getting anything because they're not producing anything. You're losing raw material because if it's talking a paper machine or something, I'm producing garbage until I get the process back up and stable. Well, that garbage is valuable material that's going in the garbage. I can't sell. I'm still using power, I'm still using resources, I'm still using all these things, but I'm getting nothing for it. And I'm losing customers because if I can't deliver, I've given my competition the best excuse in the world to take my customer away from me. Customer says, look, I've got other commitments. You either send me what I need now, or you know what, your competition's waiting right here. He says he can give it to me tomorrow. Guess what? Sorry, I love you, you're a great guy. I have to be in business. I'm going to go to him. And now that I'm going to him, it's going to be a lot harder for him to come back to you. Next question is, how long can your inventory really last you? Well, companies are going to smaller and smaller warehouses, smaller and smaller inventory. They may not carry every product in inventory. Well, what is it going to last you? Hours, days, weeks? How long can an outage really last? How long is it really going to cost you? Then the other things are, what is the cost of an at-work accident? Okay? If somebody gets hurt because they're working on a piece of equipment because of arc flash or because they were inside there and they got a shock and whatever that means, time off work, what's that really costing me? Well, my production's down. Maybe the equipment got damaged when the guy got hurt. Or maybe I had to shut it down because workman's compensation's been in there investigating. Either way, I'm not producing. So not only do I have downtime, I may have investigation. I may even have the plant closed for a period of time, which definitely means I'm out of business. And what protection does your old equipment really provide with respect to arc flash? There's a lot of plants out there with very old equipment, well before anybody even thought of arc flash. What about those pieces of equipment? They're still good, they're still running your process. You can rip them out and replace them, but that doesn't make sense. You can enhance their safety, but how? So that's another thing you have to look at. Do you have potential problems that are going to cause you exactly what we just talked about here?